Hello and welcome to Next Gen Engineering from Ansys, part of Synopsys. I am Dr. Arun Surendran, Principal of Trinity College of Engineering and Strategic Advisor to Axia Technologies. We are having this conversation in the sidelines of IEEE Space 2025 conference in Bangalore. And joining me today for this conversation are two extremely experienced experts. And I have been doing my research for the last 2-3 weeks, trying to pick their brains so that we can have a wonderful conversation. So for those who are listening at home or in office or on your way to work in the notoriously long traffic in our mega cities, please grab a coffee, relax, because this is going to be around a couple of hours of covering a wide variety of topics. And joining me today, this morning, extremely special guest who needs no introduction, Dr. S. Somanath, the former ISRO chairman, who has led us in wonderful missions like Chandrayaan 3 and Aditya, and who started his career with the PSLV launch vehicle. And today, he is supporting the Andhra Pradesh government and also the Vice Chancellor of Chanakya University, among the many other leadership posts that he holds. So welcome, sir, to this conversation, Next Gen Engineering. So great to have you. And joining us is Jayraj Nair-san, as he is based out of Japan. He has 35 years of experience in great companies, like starting with Infosys, then Intel and Microsoft, and now with Ansys, part of Synopsys. He has his education from MIT on systems engineering. So looking forward to your insights as well as we converse. So as you can imagine, I'm truly excited to be picking both your gentlemen's brain today. So this excitement, we are in the first quarter of the first century of the new millennium, is getting over 25 years, 50 years since Aryabhatta launched. Are we truly in exciting times? What excites you about working in leadership in these times?
I've been in space domain for last 40 years. Possibly I would have seen the early phase of the space era in India. Of course, what was happening outside India is something phenomenal. People were landing on the moon, and India was still thinking of launching some rockets. So that was the time that I joined. And that was the time that I have seen most of the failures of the yesterday years, which we overcame while we worked on PSLV and made it into a historic rocket of India. Today, looking back, I'm really satisfied and happy to see the growth in space sector in India. Not only that, we created an indigenous, we say the homegrown capability to build rockets and satellites, but beyond that, we were able to create inspirational stories around it, like going to Moon and Mars, and that too at extremely low cost in comparison to what others could do, and make an impact in society. Beyond technology and demonstration, it actually transformed the sector significantly towards governance, utilities, space-related applications, which was a thrust area for us. So all this was done at extremely low budget and capability, among other challenges that we faced in terms of industrialization, production, technology availability, and things like that. And so the journey has been really phenomenal. But we look at around the world, now things are changing dramatically. Yeah. And so we are also trying to see what you should be placed at a point when the world moves in a direction, especially in the space domain. So we have a vision now created for the next 25 years. And that we will discuss on that a little later, but then that is what is keeping me very excited, yes.
Marsan, this is like incredible silicon to systems era, right? So if you look at any intelligent systems that people are building today and for the future, everything is powered by silicon. You have software defined systems, and then they're all AI infused now. Yeah. So from an exciting time perspective, literally the whole computational power, the computing technologies that are coming together is transforming humankind literally. I mean, it is anchored on technology. What better time to be a technologist, right? A technologist and an engineer. So it enables you, it powers you, it accelerates the way you build things, get it to market and deploy. So overall, super exciting time.
There are some technologies which are in the nascent stage. So I remember we talked about Neuralink and the possibilities that bring in. So where do you see us going with mobile technology in Neuralink?
The space and this, if you connect, I think I would like to speak like that, which will be, of course, Nair-san will speak in a different direction. But then when we talk about communication, I think the space is becoming an integral part of the new gen communication infrastructure. where you will be delivering high throughput from the space directly to devices. It's not just delivering that, it will also be collecting information. So in the network of things that is going to emerge in the future, where we will be connecting everything to everything. Okay, and that will be, the space will be an integral part of it, because without that you will not be able to connect globally, which the space provides you that type of an architecture or a capability, which is very evident now. Now it's still not the direct device, but it is going to evolve. Now you talked about Neuralink. That means human need to be connected. Yes. Okay, you talk about a mobile phone getting connected, but then how you get connected? You will be identified as a node in the whole of this system. So if human beings ever to get connected, they need to interface with the devices, because we are not an electronic device, we are a biological device. A biological device to talk to an electronic device, you need to talk to that in digital mode. Of course, we are electrically driven life form. So we have a signal structure. And if you are able to interface the signal structure of our brains to the signal interfaces of devices, then we should be able to communicate. And this is only the translation of these two languages need to be understood over a period of time. I think this is what the Neuralink and various other human-machine interface systems are now trying to reach. Possibly the research is in the early phase, but we will be slowly able to control devices, give and experience the sensory perceptions, rather an augmented sensory perception, which we know today all our sensory perceptions are the vision, the touch, the light, sound, smell, everything. How can we augment it using other inputs that will come? Like fear. Can you induce fear? Can you induce excitement? Can you induce everything? I think whether these things are possible through not actually putting it in front of you. So this becomes and similarly that also goes to a next level of learning. Can you learn things faster than the current way of learning through putting input through our physical sensors? Now that's the only way that we can actually learn. Can you really learn faster? Can you make new connections in the brain using external stimuli? Is it a real possibility? I am really excited. These things definitely will happen, and one day human and machine cannot be distinctly different. They will be the same. And this is the day I look forward.
You were talking about your mobile phone being transformed into a robotic assistant.
That is a different thing. That is a one phase of change. For example, what I want to tell you, that you have a mobile phone now, which is a device which is away from you, but you have to interface again through your sensory perception. You touch it, you see it, you hear it, but then after some time you will not be doing it. You will become embedded into you. Okay, so even before that, there is something else going to happen. That mobile phone will transform itself into a robot. This is what I hope, and I am very sure it will happen, because whatever you can pack inside a mobile phone has already been packed. For example, your clock, your newspaper, your television, your phone, your voice recorder, your scheduler, your notebook. You can think about anything that has been possible to be transferred has already been put into it. Now, what more you can put? Now, what you need to put is more of physical in nature. Can you do some physical activity, like taking care of the home, preparing food, cleaning up the things, gardening, watering, things like that? Then you will be more free to do things other than those type of stuff, monotonous stuff. So I believe that a robot will evolve out of the mobile phone now, integrating a robot and a mobile phone, or maybe much before, actually connecting it to the entire net to draw the computational power and capability of all of that into it, so that it becomes a teacher, tutor, mentor, friend, colleague, everything.
Emotional support.
So that's what is going to happen over a period of time.
Right.
So I think that's how you can get connected to the
network
of things.
Yeah.
Yes.
If this goes into the system of systems kind of perspective, right? I'll just share a couple of examples on the BMI side, brain-machine interface. I think the advancements in that space has gotten significant over the last 5 years.
Yes.
Particularly the ability not just to read these neuron action potentials in the brain, which are firing, but also to send actionable control signals, activating neuron action potential. Like you mentioned, the analog or bio system to digital system transformation. There are now new ways of collecting digital signals, electrical signals, and then sending them over some sort of communication method to some other parts where you have to get the signal to reach to activate some body part, right? So the brain-related body prosthetics, or brain prosthetics they call it, that is affecting a lot of people, especially some have cerebral damage, some have spinal damage. That technology is actually in implementation stages today. And so what you are going to see downstream is going to be much more exciting.
We are already talking about reading signals from plants, how birds and plants communicate, things like that. So quite exciting times. But I want to take you now back to your school and college days, or days as a starting engineer. What are some of the technologies or learning tools that you wish you had at that time?
If I think back, see, our questions were not answered at that time. See, we had a lot of questions, we had a lot of concerns or a lot of ideas, but there were no one to clarify to us.
Yeah.
The teachers were ill-equipped at that point in time to clarify anything to us, or they were impatient, possibly due to their non-awareness or the
overload of work. Yeah.
No, rather they didn't know about the world. But today the changes have happened in which you don't no longer depend on teachers, to clarify your doubts, because you ask this question to systems now and you get answers. Now there is AI there, so it answers in some way, some form or the other. But then let us look at what is the challenge the present generation of students face.
Right.
Because the problems students face are one and the same at that time and now. Because the questions today are different class. Okay, they are not of that class of just to find out clarification or queries, but they want to know more today. The more is more in terms of experiential. For example, he wants to see how something really functions. Okay, he wants to actually know how to achieve something beyond what you are available here. How I translate an idea into something reality. So you need to have something beyond what is question answer possibilities, but idea translation to some conceptual ideas faster than, it cannot take prolonged time. So this needs tools like simulation, this needs tools like virtual reality, it needs interfacing your ideas into something and then getting some result out of it, and then experientially understanding it through cues of virtual and physical things like that, so that he can iterate and then solve his problem. So the generation's challenges today are of different class. I think the tools are also emerging over a period of time, and I believe this is going to be the interesting stuff for the next generation of students.
How to use the tool.
Yeah. I agree with Dr. Somanath, right? That light part is what was missing during the era, right? It was a conscripted, defined set of push of information that we could not assimilate, and we always wanted to apply it and use the understanding it to fundamental extract. But in my time, I think we were just going through the computational transformation. So I had 8086 based systems which I was trying to program. One little training board shared amongst a bunch of people. So it was very difficult to do good programming. Lack of compute. Today, you have incredibly high amounts of computational capabilities on the back end. Yeah. So that's the big transformation.
I used HP 9000 to start with. The PC was not there at that. Even 8086 was not there.
Of course. So 8086 is the initial board I started. And then at that time, that was like the 16-bit processor. And then the 8-bit.
8-bit.
As the 16-bit 80286 came about, I wanted to get more and more of it, but the ability to get the resources that could enable you to apply these questions and answers was difficult.
Yeah.
But it's funny, after I moved to work for Intel, almost like 20 years later, I got a kind of programming the 80286 book autographed by the architect of 80286, which I was waiting for a long time ago. So yeah, that was one of the experiences.
Just to showcase that I am a slightly later generation, we had things like BASIC and Fortran.
No, we also had BASIC. In the HP 9000, there was GW BASIC. We were programming in GW BASIC.
Now, taking that to, you partly answered about what youngsters should do.
Yeah.
So proactively, how can the nation or organizations as a whole think of training the workforce of the future?
Essentially, the educational system requires a revision. So that's something very difficult to implement. Its scale is very huge in India. So the availability of tools to enable that change is really slow and painstakingly, very, very difficult. You need to put in place things. So even schools or primary schools and educational systems where this need to be delivered, we can't dream of it even now.
Yeah.
But then let us not lose hope. The idea that is that we must slowly induct the modern tools of learning into it. So one of the things which we should do in universities today, at least in the higher education place, is to enable advanced learning. What is that advanced learning? The classroom learning has now, I think in my opinion, ceased to exist now.
Okay.
For example, the going there and listening to somebody's lecture on the board using Blackboard, I don't know whether it is relevant at this moment, but for a curious student who wants to learn, you can't wait till a professor comes and lectures to you today. I think you have an ability to learn it in advance and then go and sit in the class for a clarification.
Flip classroom.
I think the change has already come. But for somebody young people who is not yet entered into education, possibly you still have to teach them. The teaching has changed, I think, entirely. I think it's no longer teaching applies to even in school level, advanced school level or undergrad level. It is more of clarification, preparing, mentoring. I think this is one type of thing. Second part of education has to be, I believe that there is no cutout places, for example, domains, subjects, which are very, very well structured around some boundaries. I think those boundaries are all gone now.
The silos.
Okay, so silos, right word is silos. So the silos have vanished. So there is continuity of domain today. The way in which the biological sciences are gone into computation, the chemical sciences are gone into computation is an example how it has become so much an engineering in biology rather than biology and engineering. I don't know. So that way, if you mathematics, how it permeates everywhere. We were learning mathematics as a tool to be not to be looked at connected to other physical sciences. I think later we understood the linkages, but then early phase of our learning, mathematics was taught as mathematics. Of course, mathematics has its own beauty, standalone, but it's connected to the rest of the physical sciences. This connection is still missing in our teaching process. So, like we normally say, language cannot be taught from the alphabet upward. It has to be taught from feeling downward. So I think this is a change of education that is needed today.
I think I agree. The syllabus that you first mentioned, right, about how the information flows are available to today's generations. You have multitudes of data sources. You're inundated with information. Now to synthesize and figure out what is the right information, how to consume it. So the delivery system is completely different in today's generation. It needs to be transformed. And there are many ways to consume it. Second part is the curriculum and content. So like Somanath said about interdisciplinary. Everything cuts across everything. Math, not just math, physics, chemistry, biology, everything is interconnected. Unless you have this ability to look at a problem and a use case at a very high level and apply all the fundamental sciences to understand the problem, ask the necessary questions and then solve it, that is the kind of students and engineers of tomorrow that we generate. So that means not just a radical change, but in content, also the delivery mechanism.
That it's about situating the learning, if I can put it that way, because why do you learn matrices? Why do you learn, calculus and partial differential equation? When you are a first year undergrad student, you have no idea where this is taking you till you come into engineering and then you realize you are telling me life itself is a partial differential equation at some point of time. We can look at it that way, right?
Yeah.
So I think it's up to the mathematics teachers to gain awareness about different.
No, it is. There is some fact in that what you mentioned. See, ultimately, why you learn, it's for enjoyment. No, it's not for job. Okay.
Joyous life. Yeah.
So the joy is the result of learning. No, not really the
job is the result.
Job is not the result of learning. So unless you are able to do that, you are not going to create people who really will deliver something fantastic. You will create people who will do work for you. I think the purpose of education is to create people who are at a higher level of thought process. Okay, not really workers.
Yeah.
Of course, workers are needed for the society. So, but then the purpose of the education should always be for the best ever that can come out of the system.
Exactly.
And it's not meant for the routine stuff. So if you think like that, the first you should teach them the beauty of everything.
Yes.
Okay, it's beauty of learning means beauty of mathematics, beauty of physics, beauty of biology, beauty of life. No, that part must be first taught, then the underlying principles, then the underlying equations, then the underlying math, underlying.
Yeah, so
So you need to come from the top to the down. No, you should first take a flower, look at its beauty, see the petals, how soft they are.
Then
And
the biology.
Then you should go into it and see the seeds and then how it came out, how it reproduced. No, I think this is more pictoriously told, but then
Yes.
reality, how to frame a curriculum, how to frame a textbook, how to frame a content delivery in that direction is an art. I think it requires, I have seen some books of this class who dealt with subjects of that nature. But then I got excited by such books and reading. But then unfortunately, it's not the general stuff available in schools and colleges.
I think two of the biggest silos that still is art is different from science. If you're
That's
a
again
mathematician.
another story. For example, how do you connect literature and music and art to science? I think the connection is now very, very evident because of the tools that have come. For example, take the music. Now you can synthesize beautiful music digitally. You can make a colorful painting very, very beautifully digitally by your very little interaction. Yes. Earlier it was not possible. Now it is possible, and you can see the link. How do you understand colors? How do you understand hues? How do you understand the prints? Now digitally understanding is now enabled us to understand the physics behind it more deeper than earlier used to be.
I just add one more thing to it. Is in terms of learning itself, it's not a discrete event.
Yeah.
Like what we have these containerized systems about high school, middle school, undergraduate studies, graduate studies. Lifelong learning and continuous learning is the essence of it. Today, I learn more every day by such interaction, such reading continuously, unless you keep up. Everything is very different what I did 5 years ago versus 10 years ago versus 2 years ago.
I think whenever I ask somebody to think of a person working, they invariably think about somebody sitting at a computer or reading a book. They never think about interactions as a way of learning and understanding, or experiencing as a way of learning. So when something like Chandrayaan 3 happens and then it's broadcast and school kids are watching, like you said, they realize that there is so much to aspire to. Right? You're a 4th standard kid, barely starting up on science, but this is where sky is the limit. So when we have such missions, how can we do them with remarkable confidence? Because that's required too. When you're planning and the whole nation is watching, you have had your history of when missions were failing. So I remember we met when Chandrayaan was on its way, and you were remarkably calm about it. And then I remember on the day itself, like you said, I came to work as a regular day. This was going to land towards 6 o'clock in the evening. So I'll just sit extra hours in the office to finish this off. So how much of testing and safety and redundancy go into preparing and planning?
Your question contains so many elements which requires discussion on various things. First thing is that the Chandrayaan 3 mission and the success gave confidence to people who are watching, especially from country like India. There is somehow a belief that these are something which is beyond our capability. That myth is broken. We were able to do a very successful mission, and we know it is built in India using our own people who came from backgrounds which are very common in India, and they were brought together under an organization, and that organization was able to transform them to build such a complex stuff. Now, this gives confidence to ordinary people that I can also aspire to do something, though not Chandrayaan 3, but something phenomenal in life. I think this is very, very important. Having confidence on ourselves is the first step to having gained something. So you have to imprint that in the minds of young people. I think this mission did that first step. Second is preparing people and giving opportunity for such things. Everybody won't get opportunity to do such things. Yes. So organizations like this, creating such organizations to do such fantastic work is the next step. Where these people with great aspiration, they come out of institutions, where will they go and work? Yeah. What they will do? Yeah. And how to create an environment for them to do such things. This is the next step. So this requires all of us to contribute, building institutions, building laboratories, building private enterprises where creativity, new invention, things can actually happen. So this is the next step of a government or a nation that need to be preparing it. Otherwise, they will all become disillusioned. Okay. So this step will happen due to many reasons. It requires a financial situation, requires political stability, it requires vision, it requires societal support, especially to create technological progress. You definitely need all of this. I think this is an ecosystem which people like us should speak about it, so that decision makers understand it is the importance of creating such institutions. I'm very happy that recently government has taken actions to create a electronics ecosystem in this country, semiconductor ecosystem. So it is a next step of creating an ability to transform those ideas into some products. So people with bright minds who are now migrating may have an opportunity to contribute here. So these are the steps that we need to do, and should not be limited to that alone. There are hundreds of opportunities that can be created in this country, and India is such a vast country with so much of potential.
Nair, you've been around the world, So
I know this is exactly what is needed. It's not just about content development, but to get the entire ecosystem working for you in terms of skills, workforce development. The example that you used about training 50,000 technical people in the manufacturing process yesterday was like incredible. Unless there is a workforce to sustain the vision and kind of enable it and make it a reality, and these are just ideas on paper, right? So that development of workforce, skills development, we actually started to do a lot of big focus on the academic programming. Run not just content creation and get teachers to build net new curriculum, but also to run competitions. So many smart kids, when they come into these hackathons, and this CanSat is the satellite, CanSat satellite, right? All these ISRO runs that particular event.
Yes.
In all these competitions, you get the ecosystem to mobilize, come, participate, win some recognition, see they contribute to the effort, and make the entire ecosystem develop. So it is curriculum development, content development, getting people together, sharing information, free tools and all, that it should be very, very easy to have, less friction. Get tools, get software. In fact, I learned most of my simulation engineering tools by becoming a student and downloading the free version student edition. So my youngest son is only 13, right? He's already SD1 certified.
I learned Ansys myself. There was no tutor for me, of course. Self-learning. And so many other tools like MATLAB, or you talk about every software. There was no tutor, of course, at least that
I remember one of my friends back in the undergrad days, when they came for placement interviews, they asked him, what are the software that you know? And he said, anything with a help file. I don't know anything. Exactly. Navigate to it. Just need that help file and I'll be able to teach myself. That kind of confidence should come. But I'll just go back a bit towards the testing aspects of it. So much of sensitive electronics goes into this, and then we are operating in low Kelvin, high vibration shockwave systems. So how much of simulation is helping us validate that? And
so much. I think nowadays the simulation plays such an important role. It's not limited to this alone. The ability to do studies on functional system, for example, electromechanical functional system. If you take an example which you mentioned, they go through electrical performances, which is one class of work. They also go through mechanical stresses, of thermal, vibration, loads, etc., and also goes to fluid interactions sometimes. So it goes to a multi-physics solution domain. So it will go through different layers of analysis. First thing, it goes into an engineering functional design where you put functional systems into one place. Then you go into each and every layer of analysis. First, somebody will do thermal, somebody will do fluid flow, somebody will do structural loading, somebody will do a dynamical analysis. Then you will look at signal integrity, thermal fluid flow, etc. Right. And finally, you need to look at integrated way. Many a times this integrated way is a very tricky thing, because the integrated way to look at problems becomes a real problem in computational domain. For example, the variables that defines the problem are of one class or one type of problem. The variables that define for another class of problem are, we normally call them field variables. The field variable that defines the physics of the problem, the physics of the other problem, physics of this problem, of a different nature. And this is where the knowledge gets integrated. If you can integrate these field variables into one class of thing, then everything can be solved in one go. Today, the multi-physics problems work in a domain of translation. One field variable structure to another field variable structure, and they connect it through a interconnection language.
Yes.
And they solve it still. But then this is, I believe that you will find a physics to solve all of them in one go without understanding the difference between these variables.
Frankly, I think that workflow and the process that interconnects different functional and different physics phenomena. So multi-physics, of course, as you mentioned, structural and CFD and all that is done, but thermal, signal, power integrity, all those capabilities have to transition models across them, and then holistically at the systems level or the system of systems level validate it's good to go.
Yes.
So multi-physics is one aspect. I think the other interesting aspect that we struggle with and at the same time are working on is the scale factor. Like as you said, the resolution of input and output that comes out, just take an example of a transistor in a semiconductor.
Yeah.
You're operating at nanometer scale, 10 to the power minus 9. And then you look at space, your STK, you're looking orbital distances in the millions of kilometers. So you go from 10 to the power of minus 9 to 10 to the power of 9, which is 18 orders of magnitude.
Yeah.
So how do you actually get models that can transition scale in multi-scale as well as transition physics and then holistically present a good answer?
You mentioned to me earlier something that's very interesting, that these tools have become very easy, to use, which is taking people away from the fundamental physics aspect of it. So, boundary conditions are being, because it's so simple to punch something in and you don't have a feel or the sense of what's coming out of it. I mean, that should be something young engineers should be wary of.
That is very, very important for young people. I think this varies from domain to domain. Of course, the experience, knowledge, skill, we call it this type of terminologies we use to describe this capability. See, when you solve real problems in life, the real problems are not computer problems. No? Real problems are down in the field. They have to work, a robot need to work, a system need to function under extreme situations. And when you model and translate to a digital domain to analyze it, many times the physical nature of the problem is not fully captured in the digital world.
Yeah.
So the extent to which it can be captured are defined by the properties of the system. Both could be physical, the boundary conditions that define the system, and the constraints that are offered on this. These will determine the result.
Yes.
So many a time people who actually do this work don't have first time seen it. For example, I talk about a bearing. Okay, bearing for him is a simple model.
He's never seen a bearing, the material of it.
For example, for a fluid flow, a shock wave is simply a shock wave. Okay, there is a shock wave. What exactly is it? What is the physical nature of the shock wave? The fluid flow you talk about, boundary conditions of heat transfer.
Yeah.
For example, the convective heat transfer coefficient at the boundary of a fluid flow. Many people I have wondered, they don't understand what exactly is that number. There is a number.
Yeah.
What is the meaning of the number?
Yeah, feel for that
What
number.
exactly means in terms of reality of fluid flow. So we need to go deeper into understanding the molecular nature of the heat transfer, how it controls the heat transfer at that point. I'm talking about the H, the value we call convective heat transfer coefficient. What is the meaning of it? And how it altered by the nature of the surfaces, the nature of the fluid, the pressure, the fluid. You need to look at the numbers and understand it has some meaning. So this aspect, unless you have, your model will have that much of deficiency.
Yeah.
It may give you something. Then there is a problem when the tools become very, very advanced. You have a tendency to lose the physical sense of everything. And this is something which you have to guard against all the time. In an organization where you actually use these tools, you must also ensure people who understand the physics.
Now, as you said, the algorithms and the mathematics is fundamentally the same, even though it's now orders of magnitude of computational power behind it. So instead of running something in one shot, writing in one time, you have millions of runs, hundreds of millions of runs that you can do on different resolutions. Maybe at a higher order of magnitude or resolution, you can run with lots of simulations. But physics is the key, understanding the physics, experiencing it. That knowledge is very difficult to digitize.
Yes.
Sometimes there is the gut feel, the gut instinct, but you have to. The model actually cannot capture all of it, but can capture some of it.
Yeah, the issue of innovation. If you really improve, do something better, it will come out of only the sense of physics. It will not come out of the tool. The tool can do only certain level of improvement. Of course, it can give an optimized solution in the given system, but a drastically different solution will only come with the people who have an innate understanding of the system rather than the way to solve a problem.
The tool is
It's an enabler. Tool is an enabler.
tool is only as good as the tool user. So it cannot, inherently
So
make.
we should promote people who will develop that type of knowledge beyond the tool, beyond that.
This goes back to one more point, which goes back to understanding multi-domain competencies, interdisciplinary skills. Those are very important.
And how do you validate the simulation thing? It's again going back to the
The
feeling.
validation is the key. I think validation has been happening all throughout the tool development process. It's a process which continues. When the tools got developed, even for the case of Ansys, I am very sure about it. It has gone through a history of development and validation throughout the industry interface. So any software tool developer has a need to connect to the real field and then validate continuously and improve the structure of it. And through that, it becomes acceptable to people.
Yes.
So the validation happens in different level. One, institution level where it actually used. You will do the analysis. You will do a physical testing to corroborate. And this, it will actually function in real life.
Yes.
And this is one validation case for the tool manufacturer. And he gets thousands of such validations across the industry domain. That becomes his greater validation.
Yeah.
So it happens in small level where an engineer works on a problem and makes something to validate, to the organization which actually makes the tool also. He gets huge amount of feedback. And because the feedback is very important, because experience of one user to another user is again different. Okay, so they must be open to understand this input that will come out of the user's experience into the tool modification. I think it's a very, very important tool. I think many of them understand it very well.
Dr. Somanath, just to interrupt that, Dr. Somanath just defined my kind of role too in this process. So, in my role as CTO or field CTO, I engage with customers. I work and try to understand their use cases, at the same time solve their problem, add business value, add fundamental societal impact. But on the back end of it, I take all the inputs and feedback, and our product engineers go and modify and modulate the products that we are making to serve the customers we serve. So it's like a bi-directional pathway. That's exactly what needs to be
you
done.
talked about going multiple times back to Ansys in Trivandrum.
We have done that with Ansys. Many of my engineers have been interfacing with Ansys throughout our development time, and I am very happy that some inputs from us has improved Ansys, and Ansys helping us in another way also. Okay, so it's a give and take situation.
I'll segue on to something which we mentioned in the context of Chandrayaan about the country being motivated and it being a national mission and so on. The next one that's coming up, the big one, is Nair, where we have the NASA ISRO collaboration. So, how much of space is collaborative, but how much of it is strategic national interest being kept in mind? And so
I won't differentiate like that in saying that this much sector.
Am I siloing again?
No, again. See, the very important aspect is that we need to have our own capability. If I have to talk to you, you won't respect me if I am not of that stature.
Okay, so it's like talk softly but carry a big stick.
So
Carry weight,
so I need to develop myself to a level that I can talk to you on par.
Right.
So this is where that cooperation actually happens.
Right.
So our goal today is to raise our bar high enough to be respected across domains. No. So in terms of NISA, I see that very well, because when I look at NISA, more than a spacecraft that is being built, it is a joint mission in which there is no money transfer is involved and technology is involved in equal terms. So that's where that we are able to talk to somebody in high end in those type of development in the US with Indian counterpart. So that establishes a certain competence level of our level, and that's what I'm more proud of. Okay, for example, you look at NISAR, it is a synthetic aperture radar satellite with two bands, one with L band, another with S band. The S band comes from ISRO, L band comes from the US, and they work complementarily in a single antenna. So there are transmit receive modules in the spacecraft which consist of S band transmit receive module as well as L band receive modules, and the algorithm for the software is written by each two different agencies and then synthetically managed to understand the the physical reality through two signals processes. So this is where the contribution of both the people are coming. And the launch is happening here using our rocket. The bus of the satellite is by us, whereas the component of the antenna, the deployment mechanism, and the L-band SAR is from their side. So there is a joint work. When you do joint working, enables us to understand culture of organization. This is the next step in cooperation. It's not developing alone. You are working to become a global player. If you want to become a global player, you need to understand how others work. And that's the example of why Axiom mission happened now. We want to understand this. So you raise your capability only when you understand the ecosystem and other people in the system. So collaboration helps you to raise your bar and also to build a friendly ecosystem really. Irrespective of all what is happening around the world, we still talk to each other.
And that ecosystem is key to advancing humankind, right? It's not just we are not living in our own little well. We are part of a global community in one way.
Yeah.
Just to add to that, I think if you look at the tools and technologies that can enable better collaboration, one area is the digital engineering.
The model,
Right? So you have to have information digitally. You said the L-band is theirs, the S-band is ours, all this integration is happening to have digital assets that can be easily exchanged despite all the IP protection and encryption that you want to do. That is very important and critical. I mean, you have to have a systems architecture modeler that helps you define systems architecture and its ontology across the US, across NASA, across ISRO, and then brings the holistic system of systems together. Right? So tools that enable collaboration are also fundamental to extending collaboration. I'll talk about one more thing on this is there is a movement, of course, strategic autonomy is very important. Like in the semiconductor and electronics space, I see that every day. It's like when I travel across countries, everybody wants to have a supply chain, but the reality of it is it's a global supply chain system and everybody has a role to play in it. And to make those things happen, in one way, you need good technology, but you also need good people and good processes. So that's an area where you have differentiation across regions of the world. But as Dr. Somanath said, right, you have to carry your weight to have the conversation at the right levels.
For those who are listening to us and watching us from home, whenever technical terms come in, kindly do look up what they mean, aspire to learn more. You can always leave a comment below. This will be, and Ansys will get back to you in terms of whatever we can do to help you learn more, because it's all about the learning experience that happens. All right, I want to go back to Chandrayaan, which we talked about, because 2 more missions are in the pipeline and they are international collaborations. But people keep throwing around the word moonshot, for any small corporate venture as well, without understanding the complication that's involved. Earth is moving so fast, moon is moving so fast, then you need to land on the opposite side of the moon. So much is involved. So what are we looking forward to in terms of moon with ISRO in the future?
Moon is always exciting place to go, but it's very difficult mission going to moon and landing on the moon that we learned, in Chandrayaan 2, and then of course made successful in Chandrayaan 3. The issue with moon is that it doesn't have an atmosphere. So when there is no atmosphere, the landing is always to be controlled by the propulsion. Suppose there is an atmosphere, you can use aerodynamic surfaces and control it, decelerate it, bring down the speed. All that is not possible when there is no air, atmosphere there. The second issue is moon's gravity is not uniform like what we know about Earth. It has waviness. Even the orbit is not having an equal height at every place. Typically, the orbit also varies by about 5 to 6 kilometers in a given orbit of 100 kilometers. So it moves up and down in an orbit itself. It is because of the non-uniform distribution of mass of the moon itself. Though it looks spherical, it is not actually internally having equal density at all places. So there are other issues which further complicates because you need to provide navigation. In Earth, when navigation is provided by GPS-like system, there is no GPS-like system. So you need to use sensors on board the satellite to find its own path and then land. So we use cameras, you use altimeters, you use radars, you also look at the images of that boulders and craters and then make your path to land. And surface of the moon is very undulated, uneven, and then the safe place to land is very less. And the most serious issue is the light, availability light for you to give the power. And at equator, it is easier to land. But when you move towards the poles, the sunlight is not coming, and the days are long days, and it doesn't have a very low angle of view. So it gives you very low power generation solar panel. And further it complicates by temperature variations. Excursions in temperatures can be very high. It can go down to almost 200 Kelvin and then and go to very high temperature. So these this type of things make the moon missions difficult. So many people have gone recently and then tumbled over or upon the small missions which actually, so Americans and Russians did manned missions, human missions, except no, Russians never did that, Americans only did successfully. Doing today continue to be an issue. So that's why moonshot is still a challenge. Reaching moon is still a challenge. And you have seen Americans have given contracts to almost 10 companies to develop technologies to go to moon and land in low cost means, each mission costing around 100 million. And some of them are doing it very well. So what we look at moon as a potential habitable place for human beings to go and stay for creating a moon-based economy. I think this is exciting. And that's why further interest in moon has come, and we want to go and identify a few things. One, it is Chandrayaan 1 which detected the water on the moon. And we need to understand whether water can be extracted and used by human beings who are over there. So we need to find out liquid or solid water somewhere. So the possibility of finding out is only in the pole. So missions to go to pole, drill and find out the presence of water deep down is one of the important challenge. Then second is to find out staying there for longer periods of time, creating habitable place, possibly under the regolith. Maybe caves are there and go down so that you are safe from the meteorite showers and then excursions of temperature, things like that. So these missions are packed into our future moon missions.
This is like Moonshot is beyond like Moonshot. There's so many Mars and so many adventurous missions that ISRO has been designing and shaping. Moonshot has always been an ambition and stays a very good practical ambition to pursue. From a technology standpoint, I think if you just look at all the components that Dr. Somanath mentioned, from the rockets, the launch vehicles, to the payloads that go on it, to the communication, to the orbital trajectory mapping and optimization, I think the one Chandrayaan mission itself, I learned about that slingshot method of getting there with less fuel and more optimal fuel. Even though you can refine now higher resolution, you can understand what is needed. So all of these technologies enable these missions, and I think the adventure is in shaping, defining, doing digital mission engineering across the entire life cycle of it.
As I just mentioned, we have been using extensively simulation tools to do this landing on the moon, and this happens in many layers of simulation. Our trajectory planning has been really fantastic in terms of optimization to achieve the best out of the given fuel and rocket available. So the mass was such a premium in moon mission like that. So optimization becomes very key. And another issue which you mentioned is about the communication issue. Moon has the challenge of communication, having deep space communication networks. We need to communicate over very low power signals. Are only coming from there. You cannot put high power transmitters. So we need to have huge reflectors to collect the signal. And a global communication ecosystem should exist because we are not seeing moon all the time. So you need to connect to moon throughout 24 hours and how that is only through global collaboration and collecting data across. So these are another set of challenges that are faced, not just the rocket alone. Even operating a moon mission is also a challenge.
And with every mission, we are able to upgrade the simulations we have because so much of data comes in.
No doubt about it. For example, I'll tell you, Chandrayaan 2 to Chandrayaan 3, the biggest change was in terms of our ability to use moon images as a navigation tool. Chandrayaan 2 produced the best of images of moon at 25 centimeter resolution. And this data is what is used to program the Chandrayaan 3 landing site. So we have a high resolution data which is into the Chandrayaan 3, which is used to compare with the actual images collected so that we can match and then find out where we are exactly landing. And I can tell you this data is not used by India alone. It's used by all across the world. We supply this data to every launching site.
We have the depository.
Yeah, we have the depository. We are giving it free to people across the world to use it for moon landing.
This is like the crater navigation that
Yeah,
you
yeah.
were
I mean,
talking about
the
earlier
Indian
today.
roads, crater navigation. No, but the jokes apart, we know how unlivable our cities are becoming,
Yes.
and historically also now studies seem to say this is how civilizations break apart when it becomes so difficult, overpopulated, and it takes us 2.5 hours to get anywhere from anywhere in Bangalore. How much of urban planning can space technology help?
Urban planning can be basically what satellite data can do is actually show you the reality on the ground.
Yeah.
See, when you are standing somewhere, you only see very limited space, and when you are away, you are able to see we call the big picture, the synoptic view. The synoptic view gives you a different perspective of it. Possibly, you find that there are solutions to it. So urban planners are actually compelled to find out alternate paths to decongest, alternate paths to move the heavy things out of domains, how to organize things around it. How do you put residential areas, business areas, entertainment areas in a different manner? How to bring civic infrastructure in a better way. I think all these ways we have been able to help. For example, look at digital elevation maps. One example is, if you understand digital elevation maps of a city, you will be able to plan the drainage system properly. Where the water accumulate over one rain. Many cities now get flooded in one heavy rain. It is simply because that our drainage system is very centuries old possibly. Yes. But then it can be easily fixed provided you have the understanding of the reality. But when you stand somewhere in the city, you won't even understand the terrain.
Yes.
Okay, you need a satellite to make you understand that.
I think that's where the future missions are also headed. Yeah. Talking of sustainability, I'll go back to reusable launch vehicles, right? Are they here to stay, or would we be looking at smaller missions, or do we really want to push for reusable? And what other technology fallouts happen?
Reusable rockets, they are the one who will stay. That's called reusable.
I meant, will countries be pursuing reusable?
Sure, no doubt about it. It's in aircraft, you think about it, you use 10 times and thrown away.
No.
Can you ever imagine?
Yes.
The rockets are as expensive as an aircraft. And you need to preserve it and reuse it. It's very, very important to reuse it. But the issue with reusability is that it actually costs you in terms of the reusability components. For example, it needs extra fuel. Its ability to place an X kilogram of spacecraft actually comes down because reusability also costs you in terms of the ultimate payload capability. So it actually payload cost and payload mass comes down. So you need to build a heavier rocket for reusability purpose. Otherwise, a smaller rocket would have done the same function. So it's a cost-benefit analysis. So essentially, I believe the reusability is important to bring down per kilogram cost of launching to a certain orbit. So if you look at that measure, there are many ways to do it. If the rocket becomes bigger and bigger, the per kg cost comes down. So this is one way of doing it. Reusability is because you don't have to build it again and again. You have a reliable hardware sitting there, and which has already proven you can go in it at second time.
But we need so much of sensors and more to get this thing back.
So now advanced self-monitoring systems are coming. You can have embedded systems into it, which looks at the strains, the vibration, the structural damages, health. And once it lands here, it says it's a very good rocket. You can go once again. So, and the synthesis can be brought very fast, which was not possible earlier. Space shuttle faced this challenge. After every launch, it took huge amount of money to refurbish. Because I came to understand, I was there in Kennedy Space Center for the last mission of the space shuttle. So they told me around 35 different fluids had to be filled. Entire tiles had to be ripped apart and rebonded. Then entire system has to be flushed out and cleaned and then rebuilt. So the cost was so high. So the reusability also goes with another component, that the amount of time required to refurbish should be extremely less. So that's why aircrafts requires only very little maintenance. The synthesis of the engine health comes the moment it lands. The flight path and its analysis also available. And the pilot need to look at some minimum things. And the external engineers also need to look at only few things. The aircraft is ready for flight in just 1 hour. So a rocket which gets ready in few days, possibly in few hours, will be the one which is most advantageous for us.
Yeah, from a simulation perspective, now you just have to add the re-entry aspects and all the other physics phenomena affecting the rocket on re-entry that you're going to catch and reuse into your system of systems model. And that's the simulation aspect that is additive, but it serves a bigger purpose.
Taking to a slightly tangential thing, we had two ship disasters of the coast of Kerala, even as we are building the largest port and it's breaking world records. How is maritime technology changing? What do you foresee in the future of maritime tech? Because India is taking a big interest in that.
See, maritime technology has its own component. I think in terms of propulsion, in terms of speed, in terms of cargo size, etc. But the issue is that its volume is going to increase because the international trade is increasing, number of ships are increasing, and it also requires now monitoring it because the strategic element associated with this ship traffic is also important. So observing them from space, identifying the ship, marking it and looking at rogue ships, like thieves coming and causing and smuggling and things like that, it becomes an important issue. So automatic identification from space is already there in place because they emit certain signals, so you can identify them. But many ships may go silent. So in such cases, you need to observe using images. So satellite image-based identification, which is mostly in edge computation on board, and then tagging it then and continuously observing it to find out its trajectory, and then reporting it to the information center becomes another method. So image-based intelligence, signal-based intelligence, both are infused into automatic identification of ships.
Yeah, so the same thing. I mean, as you mentioned, the AIS plus SAR plus all the images, and then it's like having a camera with a flashlight from space.
Yeah.
Right? So you get that visibility, and the power of it is in the algorithm and the integration of all these various data sources to pinpoint where the ship is headed.
We have so much of advancement and interest in drones now. Do we have an underwater equivalent, ocean equivalent of?
I believe it is, because it is being developed quite a bit, primarily because today the strategic component of shipping or seas is as equally important as a space. It is another domain of but there the things are slow, but the things are more stable and static. But issue is the information related to sea is not forthcoming that easily. So you need to get the sea states, you need to understand the currents, you need to understand the temperatures or presence of other vehicles. So you need to embed sensors in sea and then take action against in case of intrusion and things like that there. So it requires placement of autonomous systems in the sea. It could be in the form of buoys, or it could be in the form of drones, or rather underwater drones. So if we can place them and which are powered and can collect information, transmit as an IoT device to the satellite, and then you can collect information synthesize. Possibly you don't have to have any other sensors like sonars or anything. A swarm of this can actually serve and protect our boundaries.
Serve and protect, yeah.
Dr. Somanath said the ontology of a system like this can be not many small components and ingredients can contribute to a larger system that can solve this and address this.
It
Very
is
exciting.
The drone also came like that.
Yeah.
Because now you have seen drones have become one of the most powerful tools in strategic against even fighter aircrafts.
Yeah.
So you are talking about the drones more than fighter aircraft. So how it changed all of a sudden? Even a small drones costing 50,000 rupees can destroy a tank in no time.
That's in Ukraine, what we saw.
Yeah, many places it is demonstrated. So it has everything as this type of component. So same case with sea.
But the number increases, we get drawn into Kessler effect and similar issues with the orbit. Satellites, are we really getting crowded? Because that image is quite misleading, but then I understand we need to be very careful about.
The image is misleading. If you look at the image of the satellites moving around Earth, it look like all the dots are so, it's covering the entire congested. So, and it will be so in case of you put all the people around the Earth and then put them, they will not have any gap to walk. But reality is not like that. The distance in space is so huge. They are in hundreds of kilometers. They are not moving that close by. But issue is that everything is statistical. When there are thousands of, for example, there are 20,000 plus satellites in space now. So they have a probability of coming closer and creating a collision. So this is an issue, and the collision is very dangerous, and collisions have happened. So that means it has 1 in 10 to the power of something possibility. So we need to observe it and then guard against it. So this is one side of it. Then the Russell effect which you mentioned is the collision creates secondary debris which propagate into further collisions, and then it will become an uncontrolled collision scenario. Mathematically possible. So mathematically possible is also a possibility. So now the question is how we are going to protect it. The only way is to observe it continuously using ground-based or space-based systems and predict the trajectory of evolving satellite systems over a period of time to prevent any potential collisions and then make them move apart. But one example I want to tell you that even for India, with even just 55 satellites which are working, we have to do 60-70 maneuvers in a year to avoid possible collisions. This implies that the threat is real. That means they are not actually coming and going to collide.
Right.
But they were very close by in terms of units of distances. They are potential threat. They could be in kilometers. They may go apart without ever colliding. But doesn't mean that we should not watch and then check for a possibility, because uncertainties in orbital predictions, uncertainties measurements can be very, very wrong. So we want to actually have a very high degree of distance. But with time, with more satellites in place, this much of distance possibly that may not happen. So we need to improve the fidelity of the measurement, fidelity of predictability. I think this is the next step of things handling.
Yeah, no, when these objects are close to each other or get close to each other, there are all kinds of not just physical impact, also in the EMI electromagnetic space, there's a lot of interference and other challenges, line of sight interferences, all of that can become a challenge. So you should model and simulate, and that's what we do in this space as well, is to make sure RPOs are done right, all the maneuverability and collision avoidance paths and trajectories are created. It's just to ensure that you don't have a material impact, because the output of thousands of pieces is the bigger challenge to deal with.
Even a tiny speck, the momentum is so high. We can just
it is told that if you have a flake of paint traveling at the speed of the satellite, can actually pierce through you. So a human being traveling in that crowded place is very dangerous. You will be hit by bullets of paint.
Let me come to the buzzword of today, which is AI. How quickly is AI getting integrated, or are we cautiously optimistic about AI usage in space?
Absolutely not. I think everybody is welcoming AI with open hands. The only thing is we need to develop capability. What exactly is that we are trying to do with AI? Of course, in space, the domain is a complex domain. It's a technologically intense domain. In technologically intense domain, application of AI will come little later. For example, it may be still used in domains like where data-driven activities are taking place. For example, non-destructive evaluation. It can be easily applied. You have huge amount of entity data. You can find out what is good and what is bad very easily. You can use it for a large amount of data synthesis to find out flows in the design. Okay, or you can use it for data-driven designs. For example, guidance design. It's a data-driven design. You can actually achieve optimal design guidance laws based on the available data set. So such places it is used, but to do a design per se, okay, where AI can be used is a question mark. That will come at a level which is physics. Included data-driven models have to come. So you need to have more physics into it.
Not the black box.
Not the black box or data alone. I don't call it black box. It is a trained data or a model. The model has to have physics component into it, where you will be able to put components of that nature into it. So advanced AI will definitely come, which will enable us to do a better design of flow fields, or better designers of topology, better design of architecture, propulsion. Over a period of time, that will become a reality.
So we're very optimistic about it. In fact, if you look at it from an implementation standpoint, that's your very question is like, what is getting adopted? So the first generative AI component about having large language models help you with like a co-pilot, synthesize a bunch of language and data, multimodal processes. How do you help and assist? So the co-pilot scenarios are pretty real. We have our own Ansys GPT product, which actually helps you synthesize and interact with the system efficiently. In fact, one of the big focus is to engage and integrate that co-pilot scenario into the tools that you're using. So as part of the workflow, you can just go and ask a question, get the information, synthesize, and do a better design. So Gen AI per se is going very well, and it's well adopted. The two other approaches around tops-down method, of taking a lot of parameterized and non-parameterized. In case of parameterized, you can actually start generating training data, use the training data to get upload the training data and then predict, right? Train the model using your data. And if you run like 50 simulations and the simulation results are really good, you have some gold standard test cases that are part of it, it'll help you with a better design. So that model is also getting adopted quite a bit. The third part, the bottoms up, like fundamentally re-engineering and creating a new model per se, physics, and that's where substantial amount of work is being done. See, with the AI per se, requires a lot of computational capability and training capability on the back end, right? So it is not like very unreasonable to expect like lots and lots of compute hours to process the training and train the model, right? So we are going through that very systematically, and AI is the era of smart intelligence systems infused with AI. So of course that's where we are headed.
I think that past help file has now become a co-pilot, in an interactive sense. You can learn as you go along. With all this available facilities and technologies today, what kind of encouragement and what kind of caution would you advise some youngsters who are getting into startups in aerospace and defense?
There is an exciting opportunities in aerospace and defense. I will categorize them into three domains, aerospace and defense. One is an upstream domain, a midstream and a downstream domain. The upstream domain is a core technologies, big scale products development, which includes rockets, missiles, spacecrafts, or defense equipments. The midstream is more of into component design development, R&D into functional systems, and then enabling the bigger system development, where the key components come in. The downstream is application domain, where the communication, the remote sensing, the imaging, the using the data to build a business case for banking, systems, transport, etc., weather forecast. So all areas are equally important in this, and we really look at the economy of this. You find the much of the money is in the downstream. 60% or above is in the downstream, where the revenues are generated. And unless you have an active downstream, the midstream and the upstream really will not grow. Otherwise, you create a big upstream and find some downstream use, like what Starlink did. You create a SpaceX vehicle which is reusable. Then to run it, you create a constellation launch, which will drive it also. So that means both downstream and upstream should be with one fellow. Or you should create a downstream. But I want to tell, for a country like India, it's very important to create downstream significantly, which is yet to happen. No, it's happening, but unless you scale it up to a large level, it could be in strategic use, it could be in agriculture, it could be in education, it could be in weather forecasting, resource mapping, service delivery. So then there will be demand for building more satellites, and then there will be demand for building more rockets. Same is the case with the other domains. Today, you look at aircraft domain. Again, aerospace, transport aircrafts. So there is a huge demand for transport aircrafts, and everything is purchased. Now we are talking about why we are not building aircrafts in India. India being the biggest consumer of aircrafts in the world, we are not the one who is not building it. Actually, it is something that we should pay attention to it, how to build a transport aircraft. So the downstream has developed so much, but the upstream has zero. Okay, so this should not be the case. In space today, we have upstream very strong, downstream is yet to develop. So let us look at all of them, and we need to create startup companies. I will say in space, what we really need is a downstream set of companies today. That gap exists there. Upstream is already coming up. And ISRO is already created, and they are giving to industries, etc., and can be scaled up. It's a question of scale up now. But we need to create application cases. And India is such a huge country where there are huge amount of application cases. There are problems everywhere. You talked about city planning, urban planning. How much is used? I think we don't use space-based data so much in urban planning. So how do you really monetize this? This is again next question.
I love the way he classified it as upstream, downstream, and midstream. I think the downstream app and use cases and services that can generate the revenue is supposed to fund some of the upstream activities, right? So, but you have to have the vision and the ability to invest upstream, which will help. And they are not time synchronized.
They are not, because with a time delay.
This is a lot of inflection in time. But from a Ansys standpoint, and so the way we operate is to enable the startup ecosystem, right? So one of the nations, as just like the academic world, right, enabling frictionless access to software, tools, technologies that can accelerate their journey. Because if you inundate them with all kinds of bureaucratic processes and long costs and too much, they can just start failing before they even get launched. And so the idea is to help enable and accelerate their journey. And they are not very process heavy, lightweight startup ecosystem. My son is actually a startup, so I see him the way he operates, right? The idea is make it seamless, make it easy. And we're looking forward to all the ecosystem. Actually, the ecosystem is moving. I mean, we are so excited to see in all three streams, India making a significant push.
Yeah. Coming back a bit to students and college students in particular, if you look at somebody who performs at world-class level, let's say like Cristiano Ronaldo in football, you know from Alex Ferguson and others that he is somebody who practices way beyond everybody else, so that he has, in a sense, simulated that free kick 100,000 times, so that when he goes to perform, it will go. I mean, you're pretty sure. So with all these tools and the available techniques, how can engineering students in particular prepare themselves, go through these iterations, which is something, we didn't have when we were growing up?
See, there is a difference between being in college and being in industry.
Yeah.
So being in college is actually preparing you to learn stuff when it is needed in an industry. I don't think that the colleges are capable of training them to be industry ready. This is somewhere I heard about it. Many of the industry people say, I am not getting students who are industry ready. I think the industry's needs are different.
Yes.
I cannot build some set of students for your industry. And what about the next industry? Their demands and requirements are entirely different. The third industry. So a general purpose engineering student which is coming out can need to have only a capability to learn wherever he go.
Yes.
So the tools which are required to learn that new domain in very shortest possible time is the only preparation that you can actually train him for. So now, but then basic skills are important. What are the basic skills? One, in the ability to understand fundamentals. The second, ability to operate basic equipments. Okay. The ability to work in teams.
Yes.
Ability to communicate ideas.
Yes.
Okay. Ability to work towards a goal with the disciplines not only limited to him, but also other domains which are connected. Okay. So this type of qualities, if you can create in student, they will fit anywhere. And I don't find any issue. So, but if you create only people who will only read theory and have no experience of even operating a small cathode ray tube or even a small tool, I think they will find miserable in some places because they lack the physical feel. So, sometimes I feel, the courses need to restructure towards having this type of capabilities.
Yeah. Applied is the key word there, right? Applied real world experiences. The more and more you immerse them, in fact, from the very beginning of an undergraduate program itself, if you have access to the tools and technologies and you have potential customers and partners that you can actually go and practice and try it out, interning is an ongoing, lifelong process. So that opportunity we need to give the kids.
One of the new things that is happening recently is that in the engineering curriculum, which is handling in typically 4 years, the last year itself you have to choose the industry.
Yeah.
And then you can actually specifically train him towards that industry, either giving through an internship, etc. So that will shorten the time of absorption in the industry to adapt him. So he understands what exactly the industry needs. So, but he will fit in only into that industry. Okay, that is one class. So he need to find job in that industry. Possibly that is one way. So certain amount of students can always be done in that manner. So you find internships for that industry. And I will only advise that industry should come forward, picking students not at the final year, but pre-final year itself, based on their academic records, and then train them in that final year in terms of projects or equipments and tools that the industry specifically needs. So you have an advantage there.
Yeah, I actually see this happening in the semiconductor space. We have the VLSI community actually enabling some of that so that people can be absorbed, because it's a long haul to prepare kids who are actually able to contribute to the industry efficiently and fast.
But we should go back to, it's not for job but for joy that we are learning. And then you have to have a multidisciplinary approach.
Yes.
The hierarchy about this engineering being superior to that engineering, which comes as right from the entrance exam days. Obviously, we would advise the students to avoid such pitfalls.
But we can't do that. See, sometimes, I have been listening to some of the conversations in this domain. See, today there is a huge demand for computer science related courses, and no one takes core engineering. We call core engineering, call mechanical, civil, and electrical. Okay. But whether they are incapable of handling the tasks related to computer science at a later point, I have seen them succeeding. Many of them with that type of background succeeding here. But core engineering people may not really, core computer science people, their lack of awareness of the real world issues, dealing with the systems, create problem for them to upgrade them to solve real problems. They may be good in computer science, but then their ability to understand the physical problem which is in the other domains of engineering and translate this skill to solve that problem becomes weaker. So you need a mix of both. We need people in all these engineering courses, but then we cannot compel because the markets are like that. So, see, when I joined engineering, civil engineering was in great demand because infrastructure growth was happening. And everybody advised me also, you should join civil engineering. I said, no, I will join only mechanical engineering. So it happened like that. So now I believe after some time, these changes will happen. Because now colleges are offering more and more computer science courses, and
colleges are again market driven, where there is demand.
Because always market drive everything else now. It cannot be students also.
What would you advise about stellar performances in examination? We are very exam bound, mark bound.
But unfortunately, this has become a issue for all our academic domain. Because examinations are the only way to evaluate people. But then in professional education, whether it becomes mandatory to evaluate like this is some question I have seriously questioned. Because ultimately, I have seen people performing in life very differently from that academic records. I must tell you, because though I was an academic topper all throughout, but I have seen people, though not that toppers, actually did very well in life because the exposure experience in industries that gives them a different skill. So academic skill is important, but more importantly is the multi-domain skill, which is important to be developed. And the evaluation process also need to change. The conventional examination processes, what is followed in universities is something outdated, I must tell you. It's outdated. Equally outdated is the admission process also. Okay, but unfortunately, governments decide it. It is not the professionals deciding it. So, because they want equality, they want, say, for example, interviews are done away with in some of the recruitments, which is very absurd. Because they say the relative merits are not important. They look at examinations which are objective type examinations, which determine somebody's recruitment today. And we know the proper issue with such people who comes in, have no understanding of the situation. They don't know how to work with the rest of the teams. The qualities such are not evaluated. So it must be a 360-degree evaluation at recruitment, not after recruitment. I think government need to understand this. And we have to have faith in the system of people who are actually evaluating. We are solving some stray problem by a large scale impact of, which creates long-term impact, social impact, which is something not at all right, especially in professional education.
I'll start with that. It just reminded me of the interview process I went through in my first job at Infosys. So we had all this logic, reasoning, examination during the day. And then, it's a funnel system you go through and you kind of come down to physical interaction, communication, give problem, solve it. Logic, reasoning, ability to learn, that kind of skill set was top of bin at that time. And it was a very good system that as an industry was pursuing, not just grades. But let me address that multidisciplinary, multi-domain skill set. I'll give you an example of a semiconductor chip. So today, now the transistor scaling factor is tough, right? So people are now building chiplets and then stacking them on top of each other, and it's like heterogeneous set of dies put together in a package that actually is a microprocessor or a system. Now for that, you have an electrical engineer, a computer science engineer talking about power integrity, the signal integrity, the electromagnetics involved. But at the same time, you have thermal effects that are imposing, stress-related warpage of the silicon. So now you have mechanical finite element analysis of the silicon being done at the same time. So now you have to have multiple functional areas. Cooling, of course, cooling like a liquid immersion cooling to conduction. If you have two layers, the bottom layer is conducting heat, top layer is, and you're dissipating heat through the process, but the middle layer doesn't have fins sticking out, so it's like getting too hot. Right? So the placement is a multidisciplinary effort. So from a today's generation standpoint, if you're a computer science engineer, electrical engineer, a physics engineer, a mechanical, structural engineer, all of these have very valid and significant roles to play in the high-tech field, for example. So having this heterogeneous set of skills, super important, and also it's a collaboration across multiple disciplines.
Yes, there, when we start thinking about collaboration, you mentioned in passing about communication skills, right? So we need to have, if you're a scientist or an engineer, your communication has to be crystal clear, as well as motivational, inspiring when it comes to larger teams. That I think is again sadly missing from the syllabus. There is nothing being tested about how good a person can come across. I think that's something that everybody admired about you while you were the chairman of ISRO, that we got clarity of communication and inspirational. And it's great that you continue doing that, addressing college students, school students, and participating with us. How can somebody train for this?
I must admit I was very bad in communication skills in the beginning of my journey. I realized it as my weakness. So then I worked on it over a period of time. Because I realized that while I was in college, I was an introvert. Not going out, not meeting people. Completely changed. Because I realized that it's going to create problem for me. Because see, you may have wonderful ideas, but if you are not able to tell someone and they don't come with your idea, it becomes part of their idea. How can we do things? See, ultimately you get things done only because so many people believe in you. And they think your idea is an idea that's worth following.
Yes.
Okay. So you need to create an atmosphere of that where people trust you, people believe you, people look at positivity on your ideas, and that's how you become a leader. So if you have to really do well in any institution, it's not communication alone. The communication reflecting certain qualities.
That's not communication alone.
Okay. The communication reflecting knowledge.
Yeah.
Okay, it should give everyone around you that you are skilled enough to knowledge enough to be respectful. Okay, unless you have a stuff. See, for that you need to put effort to prepare. Second, you need to tell that clearly to someone else, so they understand what exactly your intents.
Yes.
So how much you translate your ideas into the verbal languages to make somebody believe, yes, this is something that is worth it. Third is about the ability to take people along. To take people along, you need to have language of compassion, you need to have language of love, you need to have language of friendship, you need to language of the team effort. That is another skill. You need to understand each fellow's needs are different. Somebody's need of position, somebody's need of congratulations, somebody's need of pat, somebody's need of money.
It's all different.
So, okay, so how do you really meet all of there? And then towards that you communicate. When you have an ability to do that, you do. If you do not have ability, you cannot do. So communication of all these are required. Then at a higher level, you have a different level of communication. You are talking to people who are much above you. Till now I discussed about peer and people reporting to you. But when people are above you, that communication is a different communication. Okay, you need to develop that communication because they are the one who will decide where you should be. So you need to develop skills at extreme end of the spectrum of people. So how do you really train people? I think this is something which you should expose people in students level, if you can do, at least to identify their weakness. As I identify my weakness myself, and I was able to correct it over a period of time. I hope this is corrected by so many people. I think today, present generation is very, very introvert. That's what I feel. But you see a lot of noise around. It's only noise that you are not seeing, but you are not seeing stuff.
The quality. Yeah, I think I'll just second what he said. Is like the depth is essential. The expertise is, but again, the analogy of upstream, downstream, and midstream is also applies here in terms of who the stakeholder is that you're communicating to. I think, and one of the biggest, I also had the same deficiencies, right? So, and I improved over time, but the idea there was less is more. Stay, articulate key points and content and get it out there so people can understand. And unless they understand and mutual appreciation of intent is not well understood,
Correct.
then it doesn't go anywhere.
But then software nowadays allows us to show much better, visualize things, to communicate. I mean, gone are the days of PowerPoint. Now we can think of 3D modeling, especially in engineering, that helps.
Every generation had its own tools.
Yeah.
Okay, so present generation has advanced tools.
Yeah.
But you are competing in the same field with advanced tools with everyone.
Exactly. Everybody has those tools.
Everybody has those tools. So which is the better way of communication?
There's one downside to it, the attention deficit.
Yeah.
Right? We get inundated with information.
Exactly.
And so communication needs to be effective in the duration.
Yeah.
You have the eyeballs of the attendee.
They need to be aware that things take time, especially R&D, something that needs to constantly apply.
The challenges remains the same across generations.
I would like to come to the last question, which is how has being an engineer influenced your philosophy or outlook of life? That immersion.
That is a fantastic question. Okay, being an engineer gave me an opportunity to convert ideas to realities. That is the job of an engineer. Because we are not inventing anything new. Really, we are only converting the knowledge available in the current generation to products and services. That's the role of an engineer. So this is something fantastic to see that I am capable of doing in my domain, create something. A creative work is something that gives you an extreme satisfaction. Anyone, in the music, art, literature, engineering. So I consider myself as a creative engineer, not an engineer who does an ordered work. So that space is really good because you have an idea, you have tools with you, you can do something which nobody else has done before in a different way, which will having your imprint signature in it, which survives for the posterity.
Right.
Okay, so that is the role of an engineer. So I have seen me as an engineer growing in that understanding. So with that understanding, I look here and then look around the world. I see that everywhere. What you see around is nothing but people's ideas, thoughts converted into reality. Anything that you talk about here. So what all bright minds are contributed to this? I am also one of them. So that gives you a humbling spiritual experience of being part of a larger movement. Taking care of, taking the tickles of knowledge from everywhere and doing something that I can do.
Yeah, actually that's what I've learned too. No, this humility, this no hubris, accepting and understanding of every input that comes your way and what you see, right? That appreciation of that context that we all live in and how minuscule a portion of our life is part of this bigger system is very important. I think we all get tripped up in our own little worlds, but the effectiveness of an engineer is to understand the larger context in which we operate. I think there's one more thing that I've learned is just, this is from one of my mentors, Shubhalal, from the Infosys days. I still stay in touch. He used to always come next to me and say, don't talk about it, do something. Right? So he's like, you can have a lot of plans, lots of ideas, but execution is where it matters. You have to get things done. So focusing on, when the opportunity is there to do something, get it done right, do the desk research, do the upstream work. There's no substitute for hard and smart work, like we talked about earlier. So those are the learnings fundamentally. To be a good engineer, you got to start appreciating everything, and then anybody, irrespective of their social and organizational hierarchy, you go to the person with the most information to learn from. So that's my key takeaway.
Anybody can teach you, something. So it has been wonderful. I think almost 2 hours we spent together talking to two great executives who are pros and professionals in execution. I think we have a lot of messages to be covered, and hopefully all of you enjoyed our interaction as well. And please do let us know the feedback. Thank you very much, Dr. Somanath,
Thank you so much.
Thank you. And Nair-san, wish both of you all the very best in all the future leadership roles that you play. Thank you.